Capacity management is a process used to manage information technology. Its primary goal is to ensure that IT capacity meets current and future business requirements in a cost-effective manner. One common interpretation of capacity management is described in the ITIL framework. ITIL version 3 views capacity management as comprising three sub-processes: business capacity management, service capacity management, and component capacity management. As the usage of IT services change and functionality evolves, the amount of processing power, memory etc. also changes. If it is possible to understand the demands being made currently, and how they will change over time, this approach proposes that planning for IT service growth becomes easier and less reactive. If there are spikes in, for example, processing power at a particular time of the day, it proposes analyzing what is happening at the time and make changes to maximize the existing infrastructure, for example, tune the application, or move a batch cycle to a quieter period. These activities are intended to optimize performance and efficiency, and to plan for and justify financial investments. Capacity management is concerned with monitoring the performance and throughput or load on a server, server farm, or property, performance analysis of measurement data, including analysis of the impact of new releases on capacity, performance tuning of activities to ensure the most efficient use of existing infrastructure, understanding the demands on the service and future plans for workload growth, influences on demand for computing resources, capacity planning developing a plan for the service. Capacity management interacts with the discipline of performance engineering, both during the requirements and design activities of building a system, and when using performance monitoring as an input for managing capacity of deployed systems. Factors affecting network performance: not all networks are the same. As data is broken into component parts for transmission, several factors can affect their delivery. Delay: it can take a long time for a packet to be delivered across intervening networks. In protocols where a receiver acknowledges delivery of each chunk of data, it is possible to measure this as round-trip time. Packet loss: in some cases, intermediate devices in a network will lose packets. This may be due to errors, to overloading of the intermediate network, or to intentional discarding of traffic in order to enforce a particular service level. Retransmission: when packets are lost in a reliable network, they are retransmitted. This incurs two delays: first, the delay from resending the data, and second, the delay resulting from waiting until the data is received in the correct order before forwarding it up the protocol stack. Throughput: the amount of traffic a network can carry is measured as throughput, usually in terms such as kilobits per second. Throughput is analogous to the number of lanes on a highway, whereas latency is analogous to its speed limit. These factors, and others all affect the effective performance of a network. In some cases, the network may not work at all. In others, it may be slow or unusable. And because applications run over these networks, application performance suffers. Various intelligent solutions are available to ensure that traffic over the network is effectively managed to optimize performance for all users. See traffic shaping, the performance management discipline. Network performance management consists of measuring, modeling, planning, and optimizing networks to ensure that they carry traffic with the speed, reliability, and capacity that is appropriate for the nature of the application and the cost constraints of the organization. Different applications warrant different blends of capacity, latency, and reliability. For example, streaming video or voice can be unreliable but needs to have very low latency so that lags don't occur. Bulk file transfer or email must be reliable and have high capacity, but doesn't need to be instantaneous. Instant messaging doesn't consume much bandwidth, but should be fast and reliable. Network performance management tasks and classes of tools. Network performance management is a core component of the FCAPS-ISO telecommunications framework. It enables the network engineers to proactively prepare for degradations in their IT infrastructure and ultimately help the end-user experience. Network managers perform many tasks. These include performance measurement, forensic analysis, capacity planning, and load testing or load generation. They also work closely with application developers and IT departments who rely on them to deliver underlying network services. For performance measurement, operators typically measure the performance of their networks at different levels. They either use per-port metrics or they rely on end-user metrics. Per-port metrics are collected using flow-based monitoring and protocols such as ITIL or MON. End-user metrics are collected through web logs, synthetic monitoring, or real-user monitoring. An example is ART, which provides end-to-end statistics that measure quality of experience. For forensic analysis, operators often rely on sniffers that break down the transactions by their protocols and can locate problems such as retransmissions or protocol negotiations. For capacity planning, modeling tools such as OpenNet, Packet Trap, NetSim, NetFlow and SFlow Analyzer, or NetCoS that project the impact of new applications or increased usage are invaluable. For load generation that helps to understand the breaking point, operators may use software or appliances that generate scripted traffic. Some hosted service providers also offer pay-as-you-go traffic generation for sites that face the public Internet. See also, Application Performance Management, Capacity Planning, Information Technology Infrastructure Library, Network Monitoring, Network Performance Management, Network Planning and Design, Performance Analysis, Performance Tuning. References